Hi, I'm David. I'm going to do a little live demo of a data analysis project that I've been involved in. So, the goal of this video is actually to illustrate an opinion I have, which is that the best way to structure your data analysis project in R is actually to use the R package structure itself. And this is what I'm going to try to illustrate through this and probably the following videos. So the context is that I've been given a set of Excel files, which are these ones here, and I'm told that these contain the monthly gas meter readouts for a number of buildings in Switzerland. So the gas, basically the utility bills for heating. So let's have a look what this looks like. All right, so pretty straightforward. We see the date when the meters was read, the year, the months, Gasbezug. I think this will be always the same thing. Stand alt, this is probably the position of the meter at the end of the preceding period, because they are always the same, they are repeated here and here. This is the position at the end of the current measurement period, and Verbrauch is probably just the difference between the two in cubic meters. And this is just, I think, some kind of identifier of the meter. You have a nice little snippet here showing you exactly how to read this data. And also, I think this file is made up of a number of sheets. So there's one sheet per building, basically. And if I open any other one, okay, it looks like the structure is exactly the same for all of these buildings, which is a good news. And you see here also the syntax for reading out an arbitrary sheet. So, okay, so before we do anything, I'll just play with this code here and just to make sure that I understand how to read these raw data files. So I'm going to need this code here, and I'm going to open a little throwaway script here. I just paste this. Yeah, that should do it. Foo, 36 observations, 8 variables, that looks fine. So these are the columns we saw. It correctly inferred the types mostly. I would have preferred dates for the first column, but okay, that's fine. We are going to fix this later. Okay. So what about the fact that it has several sheets? Let's see. I think this function called Excel sheets, you give it a path. So before I call it, I'm gonna just assign the path to this variable here. So I'm going to delete to paren and paste. Oops. Path, Excel sheets of path. Yeah, that looks good. So there are 16 sheets, and you see the names of the sheets here. So okay, so that's great. Let's assign this to sheets, for example. And then, so what we need to do, we just need to iterate over all these sheets, and I'll just convince myself that I know how to do this. So this could be a good use case for simply lapply. So lapply, the first element is the vector on which we want to iterate, in this case sheets. The function, again, read Excel. So read Excel, the first argument is the path, and the second one is the sheet. So if we want to keep the path constant, we need to pass it explicitly as an extra argument to lapply. And that should do it. So I need to define sheets. Okay, full list of 16 elements. I don't like this format too much. Let's see it in the console. So I like it because now you see there you see directly that there are 16 elements, each of which is a table, 33 observations. Oh, that's interesting. Notice that the number of observations is not always the same. So it looks like some of them have maybe skipped a month or something like that. Okay, so that's something to keep in mind. Yeah, no, otherwise I mean, I don't see any reason why we shouldn't be able to read this. So what I'm gonna do now, I'm going to create an R project. Sorry, an R package. So new project. I don't care about saving this. New directory R package. I'm gonna call it like this because that's the acronym of the project. Create the Git repository, yes. Renv. I've never used Renv, so I don't know. All right, so these are just the boilerplate files and directories that you get when you create a project in RStudio. Like the description is the one of the most important one, you know, the package, the type, the title. I'm not gonna fill those in right now. So when you create a project, sorry, when you create a package for your data analysis, the idea is that you want, so the way I typically do it is that I use the vignette functionality. So in other words, the analysis, the documentation of my analysis will be in the vignette, but all the data sets that I use in my analysis, they will be part of the package itself. And also all the source code that I use, all the functions to transform the data, this will go into the code of the package. So first things first, we need to get the raw data files in the package. The raw data files will not be available to users of the package, but it's important that we know how we process those raw data files. So there's an amazingly good helper package called UseThis, which simplifies the management of your package tremendously. So for example, if I know that I'm going to be working with raw data, I can just go use this use data raw. I'll just call it with the default just to see what happens. Okay, it created a folder data raw with a single script here called dataset. So the intention is that you fill this script with the code that prepares your R data object, and at the very end of the script you call this use data, the name of the object, override, and this will include this object as a dataset of your R package. So that means that we probably need to copy over those 3 files to data raw. Okay. And so in this script, I'm going to write then the code to process those files. So at this point, I'm not super sure yet in what format I want this to come. Okay, so I'll just iterate on this. So I know that I'm gonna be loading this readxl library. So by the way, so since this is a package used by the in data raw, this is not a package that the user of this package needs to know about. So I'll just put the it's good to list it in the dependencies of the package, but not as a requirement. And I think there's a use package, the package name, so let's read Excel, and the type suggests. So I think this updated the description file correctly. Yes, I don't really care about the version. This is just to make sure that when if someone wanted to redo the processing of the raw data files, that they know which package are used. Right. So so like I said, the path, well, now it's on the data raw, and I'll process this one first. Oh, I haven't imported this one yet. Sheets, path, and I'm gonna call the resulting object gas consumption pre, because this is going to be the gas consumption of those buildings before the installation of an energy conservation measure. So like we said, I'll apply sheets read Excel path equals path. Now if I, okay, on dataset I don't call it like that anymore, and actually the script should not be called dataset anymore. We're going to call it gascoms pre. Okay, so if I source this now, I get the data object. It's a list of 16. This is not what I want at the end. We're gonna fix that. And also it has created a folder data, and in that folder you have this .rda file, which is the deserialized version of this data object here. Okay, so that's exactly what we wanted. Now before we go any further, so what I'm going to do now, this is going to be a bit boring, I guess, but I don't want to have it this way. I want it to have like 4 columns, one for the date, one for the gas consumption, one for the site name, and one for just an indicator variable saying that this is the gas consumption before the installation. So instead of having a list of 16 tables, I want one single table which I can then work with. So what it looks to me that we're gonna, okay, I'm gonna play with this a little bit. It seems to me that we might do this by writing a little wrapper around read Excel, and I'm going to call that read gas cons pre. I'm not sure what the arguments will be yet, but I know that this is something that will be called by lapply. Which means that it will need an argument called site and path. Okay. So data frame assign read Excel path sheet. So the sheet is the site name, and what I'm gonna do next is Control Shift N. I'm going to just replace those columns with what I want, and there's the nice, oh yeah, that means, okay, I'm going to definitely be working with, I think it's dplyr transmute, so definitely we're gonna need dplyr here, and I'm gonna go ahead and declare dplyr directly as a dependency, because I cannot imagine that we are not going to use this. So use package dplyr. Okay, so transmute okay. So like I said, I want a column called date, and I don't like that we work with POSIX times when we're talking about a date. So I'll just convert this to a date. Okay, next is consumption. That's just I like to be in control of the names of the columns I use, which is why I rename verbal to const, because, you know, suppose you need to change the input data files, then I mean you don't have to, what I want to avoid is having to do a global search and replace for verbal throughout my code. Okay, site, that's a constant, and period equals pre. Okay, that looks good, and that's this is actually the result of this function that I want. So if I do lapply on this now, I guess I need to execute this. I need to define this function and I need to run it. Okay, let's have a look. Yes, that looks not too bad. There are still 16 elements and they are much simpler now. Date, consumption, site, period. Great. Now the last thing I want to do, I don't want to work with a list of data frames. I'll just concatenate them all together, and I think there's something called bind rows, which sounds like it's what I want. The first argument can be a list of data frames. Perfect. So bind rows. Well, that's it, right? Okay. Gas const pre. Okay, now if I source this just to make sure that everything runs. Okay. Okay. So we have data raw. We have a script which processes one of the raw data files. I'm gonna work on the other ones, not just now, and you'll see why. And the process data file ends up in this .rda file. So before I do anything else now, I want to make sure that I know also how to create the report. And so I'm going to iterate this way. I have something that I can write a report about now. Okay, so I'm gonna do that first. And again, to create a I'm gonna just create a vignette for this. Vignette, the name, just report, that's fine. For now, we can always change that anyway. Okay, so it created this vignette under the folder vignettes, and it put all this boilerplate, so just defining some convenient defaults for knitr. And the first thing it does, as you can see, it loads the library. So I should be able, I'm not gonna knit this from RStudio directly. I want to make sure that I can do this from as a step in building the package. So the way to do this is I go build. I think there should be an option here to build the documentation. I don't see it, so I think I need to enable something in build tools here. Generate document. It could be this, yeah, vignettes. I think it is this. Document, yeah. So if I run document now, it did something. Yes, it built report.html. Just to convince yourself of that, I'm going to delete these two guys. What was it? Ctrl-Shift-D? Yes. Yes, as you can see, this processes the report.rmd file. It produces the code itself, and it produces the HTML. If I open this now in the web browser, you can see my very small report. Okay, so one thing we can do before we do anything, we should be able to plot some stuff now. So, for example, I still have this available, right? So let's do the simplest thing I can think of, which is to plot the consumption over time, split by site. When I explore things, so I use ggplot as my graphics package, but when I explore things, I kind of like to do qplot first. Oh, I think I need to import this first. I'm gonna clean up the console a bit. So qplot xy data. So x is the date and y is the consumption. Data is gas cons 3. This is probably not what I want yet, but I'm getting there. Already you can see the yearly pattern here. But what I really wanted a separate line for each site. Okay, and I also want to plot lines, so that's gonna be probably the geom argument. So qplot date cons color is site, data is this object, and geom lines. How about that? Nope. Singular. Okay. Not bad. Not bad. This is exactly what I wanted to see. So yeah, you can see. I mean, some sites consume obviously more gas than the others. So let me see now. If I want to include this now in the report, okay. So I am going to need ggplot for sure. I'm going to separate it from calling the loading my package. And so now that I have I mean, when I do the plot with qplot, I really prefer using ggplot for the final product. So gas cons pre yes, so date equals y equals cons site line. Let's see if building the vignette works. Okay, I need to fix something about the default size here. Fig width, I don't know, 15 maybe. I think the defaults are 7 and 7, that's why. Can I just reload this? Okay. Okay, that was way too much. 50, yeah, let's go for 8. Okay, I mean, we are getting there. So let's recap what we have learned. I've started a data analysis by taking the raw data files. I placed them in the data raw folder together with a script to process those raw data files. This script creates an R object that I'm going to work on. I have full control over the format of this R object. I define the types and the names of the columns of this object. And I was able to get to the point where I begin a draft of the report of my analysis, written in R Markdown and using the data objects defined by this package here. So you can see where this is going. I am going to continue processing the other raw data files. There's more to come, and I will also need to write some code to further process those R data files, because I am going to have to correlate them with climate files, for example. And so this is code that will come and that will be part of this package as well. But for now, I'll sign off now, and if you like what I'm doing here, I'll continue next time. See you.